Dear students, in the previous module, I introduced to you about computers, its types and its applications. In this session, we will make a brief survey on the generations of computers. Generations in computer technology is a change or advancement in technology in a computer being used. Initially, the generation term was used to distinguish between advancement of hardware technologies alone. Nowadays, generations include trends in both hardware and software, which together make up a complete computer system. The world has seen 5 computer generations till now. Now, it is time to survey each generation in detail along with their epoch and characteristics. The first generation, the period extended from 1946 to 1959. The computers of first generation used vacuum tubes as the basic components for circuitry of CPU and magnetic core for random access memory. These vacuum tubes, like electric bulbs, produced a lot of heat, and the system used to fuse or fail frequently. Therefore, they were very expensive and only large organizations were able to afford it. In the first generation, mainly batch processing operating system was used. Punched cards, paper tape and magnetic tapes were used as input and output devices. The computers in the first generation used machine code as the programming language. The computers of the first generation were very bulky and emitted large amount of heat which required air conditioning. They were large in size and cumbersome to handle. They had to be manually assembled and had limited commercial use. The concept of operating system was not known at that time. Each computer had a different binary coded program called the machine language that instructed it how to operate. The abacus, which emerged about 5000 years ago in Asia, still in use today, allows user to make computations using a system of sliding beads arranged on a rack. Blaise Pascal, a French mathematician, invented the first mechanical machine, a rectangular brass box called the Pascaline, which could perform addition and subtraction on whole numbers. In the 17th century, Colmar, a Frenchman, invented a machine that could perform the 4 basic arithmetic functions of addition, subtraction, multiplication and division. Colmar's mechanical calculator, arithmometer, presented a more practical approach to computing. With its enhanced versatility, the arithmometer was widely used until the First World War, although later inventors refined Colmar's calculator together with fellow inventors Pascal and Leibniz. He helped design the age of mechanical computation. Charles Babbage, a British mathematician at Cambridge University, invented the first analytical engine and the difference engine. This machine could be programmed by instructions coded on punched cards and had mechanical memory to store the results. For his contribution in this field, Charles Babbage is credited as the father of modern digital computer. Let us see some of the early computers as follows. Mark I was the first fully automatic calculating machine. It was designed by Howard Halkin of Howard University in collaboration with IBM. This machine was electronic relay computer. Electromagnetic signals were used for the movement of mechanical parts. Mark I could perform the basic arithmetic and complex equations. Although this machine was extremely reliable, it was very slow. It took about 3 to 5 seconds per calculation and was complex to design and large in size. Atanasoff Berry computer, shortly called ABC. This computer, developed by John Atanasoff and Clifford Berry, was the world's first generation general purpose electronic digital computer. It made use of vacuum tubes for internal logic and capacitor for storage. The electronic numeric integrator and calculator, popularly called ENIAC, was the first all electronic computer, was produced by the partnership between the US government and the University of Pennsylvania. It was built using 18,000 vacuum tubes, 70,000 resistors and 1500 relays, and consumed 160 kilowatts of electrical power. The ENIAC computed at speed about 1000 times faster than Mark I. However, it could store and manipulate only a limited amount of data. Program modifications and detecting errors were also difficult. In the mid 1940s, Dr. John von Neumann designed the electronic discrete variable automatic computer, the EDVAC, with a memory to store both program and data. This was the first machine which used the stored program concept. It had 5 distinct units: the arithmetic, central control, memory, input and output. The key element was the central control. All the functions of the computer were coordinated through this single source, the central control. The programming of the computer was done in machine language. Rand designed the Universal Automatic Computer UNIVAC. This computer specifically for business and data processing application. The UNIVAC was the first general purpose commercially available computer. The downsides of the first generation computers can be summarized as unreliability, supported machine language only, very expensive, generated a lot of heat, needed heat ventilation and air conditioners, slow and bulky input and output devices, consumed enormous amount of power. The period from 1959 to 1965 was called the second generation. In this generation, transistors were used that were cheaper, consumed less power, more compact in size and more reliable and faster. In this generation, magnetic cores were used as primary memory and magnetic tape and disks as secondary storage devices. In this generation, assembly language and high level programming languages like Fortran, COBOL were used. The computers used batch processing and multiprocessing operating system. This was the generation of transistorized computers. Vacuum tubes were being replaced by transistors. As a result, the size of the machines started shrinking. The computers were smaller, faster and more reliable and more energy efficient. The first transistorized computer was TX0. The first large scale machines that took advantage of the transistor technology were the early supercomputers Stretch by IBM and LARC by Sperry Rand. These machines were mainly developed for atomic energy laboratories. Typical computers of the second generations were the IBM 1400 and the 7000 series, Honeywell 200 and the General Electric. IBM 1401 was universally accepted throughout the industry and most large businesses routinely processed financial information using second generation computers. The machine language was replaced by assembly language. Thus, the long and difficult binary code was replaced with abbreviated programming code which was relatively easy to understand. The stored program concept implied that the instructions to run a computer for a specific task were held inside the computer's memory and could quickly be modified or replaced by a different set of instructions for a different function. The high level language like COBOL, Fortran, ALGOL were developed. Computers started finding vast and varied applications. The emergence of software industry began with the second generation computers. Even though the second generation computers had advantages over the first generation, they still had some limitations like cost, size and difficulty in programming. The third generation emerged in the 1965 and extended till 1971. The computers of the third generation used integrated circuits in the place of transistors. A single integrated circuit has many transistors, resistors and capacitors along with the associated circuitry. The IC was invented by Jack Kilby of IBM. This development made computers smaller in size, reliable and efficient. In the third generation, remote processing, time sharing, multi-programming operating system were being used. High level languages like Fortran 2, 2.4, COBOL, Pascal, PL1, BASIC, ALGOL 68 etc. became very common. The weight and the power consumption of the computers decreased and the speed increased tremendously. Heavy emphasis was given to the development of software. Operating systems were designed which allowed the machine to run many different programs at the same time. Multi-programming was made possible, whereby the machines could perform several jobs at the same time. Computers achieved speed of executing millions of instructions per second. Commercial production became more cheaper and feasible. Higher level programming languages like Pascal and report program generator RPG were introduced and application oriented languages like Fortran, COBOL and PL1 were enhanced. The period 1971 to 1981 was the era of fourth generation. Computers of fourth generation used very large scale integrated circuits. VLSI circuits having about 5000 transistors and other circuit elements with their associated circuitry on a single chip made it possible to build microcomputers of the fourth generation. Fourth generation computers became more powerful, compact, reliable and affordable. As a result, it gave rise to the personal computer revolution. In the fourth generation, time sharing, real time networks, distributed operating system were used. All the high level languages like C, C++, DBase etc. were used in this generation. The third generation computers made use of integrated circuits that had 10 to 20 components on each chip. This was small scale integration. The fourth generation realized the large scale integration LSI, which could fit hundreds of components on the chip, and very large scale integration VLSI, which squeezed thousands of components in one chip. The Intel 4004 chip packed all the components of a computer, namely the central processing unit, memory, input and output controls on a single chip, and microcomputers were introduced. Higher capacity storage media like magnetic disks were developed, fourth generation languages emerged and application software started becoming popular. Computer production became inexpensive and the era of personal computer commenced. In 1981, IBM introduced its personal computer for use in office, home and schools. In direct competition, Macintosh introduced by Apple in 1984. Shared interactive systems and user friendly environments were the features of these computers. As the computers started becoming more and more powerful, they could be connected, or in other words networked, to share not only data but also memory space and software. The networks could reach enormous proportions with local area networks. A global web of computer network, the internet, links the computers around the world into a single network of information. Now, we live in the period of fifth generation, which started in 1980 and continues till date. In the 5th generation, VLSI technology advanced to ultra large scale integration or ULSI, resulting in production of microprocessor chips having 10 million electronic components. This generation is based on parallel processing hardware, artificial intelligence, AI software. AI is an emerging branch in computer science which interprets the means and methods of making computers think like human beings. All the high level languages like C and C++, Java, .NET are used in this generation. Defining the 5th generation computer is somewhat difficult because the field is still live in its infancy. The computers of tomorrow would be characterized by artificial intelligence. An example of AI is expert system. Computers could be developed which could think and reason in much the same way as humans. Computers would be able to accept spoken words as input, voice recognition. Many advances in the science of computer design and technology are coming together to enable the creation of 5th generation computers. Two such advances are parallel processing, where many CPUs work as one, and advancement in superconductor technology, which allows the flow of electricity with little or no resistance, greatly improve the speed of information flow. We can summarize the main features of 5th generation: use of ultra large scale integration technology, development of true artificial intelligence, development of natural language processing, advancement in parallel processing, advancement in superconductor technology, more user friendly interfaces with multimedia features, availability of very powerful and compact computers at cheaper rates. So, we have come to the end of the generation of computers. We will meet again in the next session on the basic building blocks of computer.